Hi, I am Zaira, and I will present to you my project entitled Automatic Alcohol Dispenser with Alcohol Monitoring. Coronavirus disease 2019, also known as COVID-19, was the new disease spread through recent coronavirus. COVID-19 has been declared as pandemic by the World Health Organization on March 11, 2020. Humans are the main source of transmission through human-to-human interactions. That is why humans were advised to adopt effective hand hygiene by sanitizing frequently with soap or greater than 60% of alcohol hand sanitizer. World Health Organization suggested alcohol-based hand sanitizers to reduce the infectivity of the disease. However, too much use of alcohol can cause harmful effects on the skin and body. It can be skin irritation, dry and broken skin, antibiotic resistance, and weakens the immune system. Preparations of alcohol may be toxic to human health and environment when misused. Alcohol-based toxicity is associated with respiratory depression. Frequent use of alcohol-based sanitizers against COVID-19 are not environmental friendly and hazardous to human health. According to Infection Control Today, when using an alcohol-based hand rub sanitizer, apply a dime-sized amount of product into the palm of one hand and rub hands together. To control the usage of alcohol-based hand sanitizers, an automatic alcohol dispenser was created. It is a device that controls the amount of alcohol used. This device helps conserve the amount of alcohol, stem infectious disease transmission, and eliminates common contact points. To build this automatic alcohol dispenser, I searched for related projects and demonstration to make this automatic alcohol dispenser work. Arduino modules L298N dual H-bridge motor controller was used to get familiarized the functions of the motor controller for controlling the submersible water pump. Next is the automatic hand wash sanitizer dispenser peristaltic pump was used to run the submersible water pump using the codes reviewed from this demonstration. Next is the automatic alcohol dispenser with Arduino. This project was used to use the submersible 5 volts DC water pump as a motor for pumping the alcohol. The ultrasonic sensor HC-SR04 with Arduino tutorial was used to familiarize the function of the ultrasonic sensor and was used to create an automatic response of submersible water pump. Next is the how to connect your L298N dual H-bridge motor controller to Arduino Uno. This demonstration was used to control the submersible water pump using H-bridge motor controller connected to Arduino Uno. The demonstration water level sensor with Arduino Uno was used to have an alcohol level monitoring to the automatic alcohol dispenser. The interface I2C 16x2 LCD with Arduino Uno demonstration was used to display the alcohol level of the automatic alcohol dispenser. Next is the build automatic hand sanitizer machine at home. This tutorial was used to create a DIY and decent case of automatic alcohol dispenser. And lastly, the Arduino RGB LED tutorial. This demonstration was used to have another alcohol level indicator other than LCD I2C. This is the wiring connection of the automatic alcohol dispenser with alcohol level monitoring. The ground pins of RGB LED, ultrasonic sensor, LCD I2C, water level sensor, Arduino Uno and 12 volts DC adapter are connected to the ground pin of H-bridge motor controller. The VCC pins of ultrasonic sensor, LCD I2C, water level sensor, and Arduino Uno are connected to the VCC pin of H-bridge motor controller. The red, green, and blue pins of RGB LED are connected to 100 ohms resistor and connected to the digital pin number 11, 10, and 9 of Arduino respectively. Next is the ultrasonic sensor. The trick pin is connected to the digital pin number 8 of Arduino, and the echo pin is connected to the digital pin number 7 of Arduino Uno. Next is the LCD I2C. The SDA pin is connected to the analog pin number 4 of Arduino, and the SCL pin is connected to the analog pin number 5 of Arduino. Next is the water level sensor. Its signal pin is connected to the analog pin number 0 of Arduino. Next is the submersible water pump. The positive wire is connected to the output pin number 1 of H-bridge, and the negative wire is connected to the output pin number 2 of H-bridge. Next is the H-bridge. The enable pin is connected to the digital pin number 5 of Arduino, and input 1 is connected to the digital pin number 3 of Arduino. Lastly, the 12 volts DC adapter. Its positive wire is connected to the 12-volt pin of H-bridge, and the ground pin is connected to the ground pin of the H-bridge, supplying all the components with voltages. This is the process of automatic alcohol dispenser. The user will put his or her hand to the dispenser. The ultrasonic sensor will determine if the hand is less than or equal to 10 cm. If it is, the submersible water pump will dispense an alcohol for about 0.1 seconds. Next is the process of alcohol level monitoring. The water level sensor will determine the level of the alcohol. If the level is greater than 300, the LCD will print high and the LED will turn into color green. If the alcohol level is greater than 200 but less than 300, the LCD will print medium and the LED will turn into color yellow. If the alcohol level is greater than 1 but less than 200, the LCD will print low and the LED will turn into color red. And if the alcohol level is 0, the LCD will print empty and the LED will turn off. Next is the testing results of the alcohol dispenser. The alcohol container has a capacity of 90 milliliters. Low was measured from 0 up to 3.5 cm. Medium was measured from 3.5 cm up to 5.5 cm. And high was measured from 3.5 cm and above. The accuracy testing was started at the high level of alcohol at 9.5 cm. It took 40 pumps to drop alcohol to half centimeter. On the 9th test, the result was nearly accurate because the alcohol dropped by 0.25 cm only. And on the 10th to 14th test, the results were not accurate because it's affected by the result from the 9th test. Next is the reliability testing. The reliability testing was started along with accuracy testing. On the 7th and 12th testing, the result was not accurate and the rest of the tests were accurate. For the conclusion, I conclude that the automatic alcohol dispenser can control the amount of alcohol used. It can help conserve the amount of alcohol, stem infectious disease transmission, and it can eliminate common contact points. This is the prototype of automatic alcohol dispenser with alcohol level monitoring. The alcohol level is at the high level. I used a jar that is tall enough to detect by the ultrasonic sensor so that it can dispense an alcohol continuously. We will see the transition of alcohol level from high to medium to low. I also used my hand to show how to actually use this automatic alcohol dispenser. Now we will wait for the alcohol level to turn into medium level. As you can see, the LED turned into color yellow and the LCD printed medium, indicating that the alcohol level is at medium. Now we will wait one more time for the alcohol level to turn into low level. This time, the LED turned into color red and the LCD printed low, indicating that the alcohol level is at low. The user will now recognize that the automatic alcohol dispenser is close to empty and needs to be refilled again.